Hello, everyone, and welcome to today's webinar. My name is Paul Adepoji, and I'm the community manager for the ICFJ Pamela Howard Forum on Global Crisis Reporting. As for me personally, since Monday, something unique has been happening in Africa. We are having the regional committee meeting of the World Health Organization, which is like an assembly or a congregation of health ministers from across the continent. And while discussions around COVID-19 continues to be a major topic, we are also seeing other topical issues being discussed. Most importantly in recent weeks is the monkeypox outbreak that has significantly spread, with many cases reported in countries where these cases had been sparingly reported in the past. And considering the misinformation that was one of the major highlights and drawbacks of the global response to COVID-19, during the early days of the global monkeypox outbreak, especially in 2022, we've also seen similar misinformation and conflict and confusions on how to properly report these outbreak, including risk of misinterpreting or misrepresenting communities that are directly or indirectly affected or connected to the disease. And considering journalists do not have Ph.D. in studying monkeypox, we understand the reason why it is really, really important to help journalists from across the world to be able to improve and expand their monkeypox reporting skills, just like we did on this forum for COVID-19. And that's something we plan to do today. And we are joined by a scientist, our trainer today is Dr. Hussein, who is a virologist and science communicator. How are you doing today, Dr. Islam? How are you doing today?
I'm good. Thanks very much for having me. I'm really glad to be with you today.
Yes, we are very glad that you can join us this early in the morning, and thank you for accepting to our invitation. For those that do not know our trainer, he earned his PhD from the University of Cambridge here in the United Kingdom, and after his postdoctoral training, he joined the Massachusetts Institute of Technology as a researcher, as a research scientist, and currently he's a senior scientist at Microbiotix, which is a biopharmaceutical company that is based in Massachusetts, where it leads several research projects focused on the discovery and clinical development of antiviral drugs. So let me welcome you properly and say thank you very much for joining us. And we hope this is going to improve the reporting skills of our journalists that are on this call today. And if you're a journalist on this call or wherever you heard that's of interest, that this topic is of interest to you, I encourage you to let us know where you are joining us from, and we always like to know where our participants are from so that we can also actively engage with you. And I'm not forgetting our viewers on Facebook live stream. If you are watching this live on Facebook, thank you today for also joining us, depending on your time zone, whether it's morning, afternoon, evening, or late at night. So thank you very much for joining us. And you can also be part of this conversation. Any burning questions, no question is off limits. As far as is in relation to monkeypox, we will table them and discuss them with our trainer today. And so please keep those questions coming. And I also have a long list of questions already for our trainer. I think our trainer has a slide that he has prepared. I would encourage to start sharing. So we'll take that presentation, and when you are done with the presentation, I'll be back for the question and answer session. Yes, full screen? Yes, you can take it away from here.
You see it?
Yes, loud and it's clear.
Okay. Okay, so welcome everybody. I'm not sure if it is a morning or evening or afternoon, depending on whichever time zones you are based. Thanks very much for joining us today, and thanks Paul for the introduction. My role today is to tell you a lot about monkeypox, and hopefully by the end of this seminar, you guys will have better expertise in reporting on monkeypox. I will try my best to cover a little bit of introduction about monkeypox and some technical terms that scientists use all the time, and you will find them in papers published in scientific journals. And I will put a lot of emphasis on risk assessment. We try to either underestimate or overestimate. So I'm hoping that after this presentation, we'll try to have a better understanding of the risk behind monkeypox. So let me go ahead and start. You're free to ask any questions in the chat box, and we can take them when we finish the slides. I promise you most of them will be answered already during the presentation, but we'll take the ones that we haven't covered when we're done. So thanks for your patience. Okay. Let me see if I can. Okay, so let's start with some general terms that are very important for understanding the current monkeypox outbreak. Monkeypox is a zoonotic disease, and the term zoonosis is used to describe infections that are transmitted to humans from animals, and they represent a major part of some of the most important human diseases that we currently face today. Transmission of these zoonotic infections involve direct interaction with domestic or wild animal reservoirs. And I'm going to tell you a little bit about animal reservoirs in a minute. And it usually occurs under conditions where humans are engaged in activities that involve close contact with animals. Also, some of these viruses are transmitted by insects. And just to give you a sense of numbers, about 75% of the emerging infectious diseases that we see today are zoonoses. Okay, so I'm going to give you examples in a minute, but most of the diseases you hear about these days are coming to us from animals. And one fact that we tend to ignore is that we are all connected. There is another important term that I would like to introduce to you, is what we call One Health. Our health as humans is tightly connected to animal health, and it's also connected to the environment and how humans deal with the environment. So our actions influence everything, influence human health, influence animal health, and it's all one connected cycle. Another term that I would like to introduce to you is the virus reservoirs. Some animals or birds may act as natural reservoirs for a countless number of viruses. There are so many viruses in the environment, we know just very little. And a reservoir host will carry the virus, but shows no disease symptoms and serve as a constant source of infection. For example, and a very famous example you guys, I'm sure, heard during COVID, bats. Bats act as a natural reservoir for several coronaviruses. They're also reservoirs for Ebola, Nipah, and so many others. And usually, as you can see in the diagram, these viruses jump from the natural reservoir to an intermediate host, which is usually closer to humans, and then we get it normally from the intermediate host. We haven't yet identified what is the intermediate host for SARS-CoV-2, but we have done it for other viruses that belong to the same coronavirus family, as you can see in the schematic. Other important reservoirs will include birds and rodents. Birds are reservoirs for influenza viruses, for example, which are around us all the time. Another term is the species barrier or spillover. There's a famous book called Spillover. Maybe some of you have read it already. Most viruses have evolved to optimize their ability to be transmitted within one or few host species, and that creates what scientists call the species barrier. However, viruses, as you know by now, mutate all the time, and they undergo adaptive mutations that would enable them at some point to become established in a new species. These genetic variations that happen all the time, as you have seen with coronavirus, SARS-CoV-2 and its variants, they help the virus, or they can lead to these viruses emerging into that they will have a new host tropism, and then they could emerge in a new animal species or humans. And these are the examples. Most of the viruses that you have heard about in the last century, they're all coming to us from from animals. Most of the pandemics that we know about from the history are also diseases coming from animals. Just to give you, to name a few, 1918 influenza pandemic, Spanish flu. As I just mentioned, influenza viruses come to us from birds. HIV originally come to us from primates. Ebola is based in bats. Nipah is also another bat disease. Zika, which is a recent outbreak that you have heard about a few years ago. These are all viruses that coming us from nature. And of course, COVID is like the most recent example that we have lived through. So these are viruses that circulate in reservoirs, and somehow they attain certain changes in their genetic material that would allow them or will facilitate their spread into other species and eventually humans. Our actions as humans play a big role in this. So we are, we played a role in all of these outbreaks. People usually point fingers to some other irrelevant reasons for continuously, we have to deal with these outbreaks all the time. But there are so many things we do every day that would facilitate viruses becoming outbreaks and eventually grow into pandemics. Just to give you examples of some of our human activities, eating wild animals, which happens in certain countries and could possibly have been the reason for emergence of SARS-CoV-2. Deforestation, we invade areas of nature and just cut the trees and establish new communities and build new cities. And that would disturb the balance between these viruses and their environment or the natural host, and we just get in the way. Climate change is another big reason of animals moving into new habitats, or vectors, insects mainly, migrating or establishing a new habitat, or like moving into another place of the world that they haven't usually occupied before, and that would facilitate spread of diseases. And finally, travel. There are millions of people who are traveling every day, and that would, in few hours, transmit or help to transport a virus that emerged hundreds and thousands of miles away to a new continent. And you have all seen this during COVID. It just happens like this. Monkeypox now is a global issue. It has been reported in 89 new countries on top of the 7 countries that was endemic in Africa for this virus. And now we have more than 44 confirmed cases across the globe. In the US, there are about 16,000 cases. And as you will see, most of these cases are concentrated in European countries and in the Americas. These are data from WHO, but fortunately, mortality has been low so far, which is good, and it's something that we have to be reassured that it's not as COVID, and I'm gonna tell you why, and I will emphasize this several times during the presentation. We have few mortalities reported in Spain, Brazil, and India, but so far it remains low, which is a good thing. It has been declared as a public health emergency of international concern. And this is the highest level of alarm ever sounded by the WHO. Before COVID, we had 5 outbreaks declared as a public health emergency of international concern. The H1N1 swine flu pandemic in 2009, polio resurgence in Afghanistan in 2014, Ebola in 2014, Zika in 2016, and another Ebola outbreak in 2019, and then finally, of course, COVID. And now we have monkeypox. So what is a public health emergency of international concern? There are certain health regulations that guide how the WHO and the members of the United Nations would respond to an emerging health threat. And under the current regulations, the director of the WHO has the authority to declare a public health emergency of international concern, which is usually abbreviated as FAKE. And it's usually declared when 3 criteria are met. When the situation is an extraordinary event, when there is a risk of spread to other countries, as we have seen this already with monkeypox, and when the situation might require coordinated international response. Declaring a fake is not to scare people, is not to panic, to cause panic. It's an important step toward preventing an emerging disease from becoming a global health crisis. So why now? I don't think we know for sure why monkeypox has emerged recently, but we can speculate. One reason is the dimension immunity. As I'm going to tell you in a minute, we had people immunized in the past against smallpox, which is a close relative of monkeypox, but the new generations are not immunized. So we have dimension immunity over time in communities. And we have increased contact with wild animals. And another important hypothesis is what happened after COVID. So during COVID, we're all hiding at home under quarantine, and then now people are going back to their normal lives. And these behavioral changes could potentially play the role in bringing people close to each other, and that could probably triggered a small outbreak of monkeypox that was lingering somewhere. And then all of a sudden, people are out there and they're meeting and they're, seeing each other's in events, or, regaining back the normal lifestyle that they didn't have during COVID. And that could potentially played a role, but we don't know exactly why, but we can at least speculate. It's a misnomer, unfortunately. Monkeypox has nothing to do with monkeys. It's not a new virus. The first case was detected in 1970 in the Democratic Republic of Congo. And since then, the virus periodically caused small outbreaks. Most of them were limited to a few hundred cases in African countries. And a handful of cases made it to other countries outside Africa, maybe by travel or by importing exotic animals. And despite the name, the virus doesn't have anything to do with monkeys. The name monkeypox comes from the first documented case of the disease in animals in 1958, when a small outbreak occurred in a colony of monkeys that was kept for research. It caused legions that are very similar to smallpox that humans know very well, which is a close cousin of monkeypox. And that's the reason why scientists call it monkeypox. However, it did not jump from monkeys to humans, nor are monkeys major carriers for the disease. And it is thought that it's transmitted to humans from wild animals, mainly rodents. There are calls now to change the name. I'm not sure if these efforts will be successful, but it's important to know that it's not really, it's not a monkey issue. It would infect monkeys, but it's not, monkeys are not the major player in this disease. We classify viruses, and monkeypox is classified within a family that we called Poxviridae or pox viruses. And there are genera under this family, and there's a genus called orthopox, to which this monkeypox virus belongs. There are other viruses also classified within the orthopox virus genus, such as smallpox, and I'm going to tell you a little bit about smallpox, vaccinia, I will talk about vaccinia in a minute, and cowpox as well. And there are two predominant strains of monkeypox. There's the West African strain, which is a milder one and has a low fatality rate of about 1%. And there's the Congo Basin strain, which is much more severe. It spreads easily from person to person and kills about 10%. Fortunately, the virus that's causing the current outbreak is related to the West African strain, which is a mild strain and usually cause few mortalities. This is how the virus looks like under the electron microscope. As you know, viruses are really small. We cannot see them by naked eye or even by light microscope. On the right-hand side is an electron micrograph of how a monkeypox virus particle looks like, and on the left-hand side is a schematic of the structure. And I don't want to go into details. I just want you to see how the virus looks like, and I want you to know that it is one of the largest DNA viruses, and it's also one of the most complex viruses that we have. We talked about smallpox, or what we call variola virus. This is the monkeypox cousin, and it was one of the most devastating human diseases ever we have witnessed in history. It kills about 30% of infected people. There was a massive global campaign in the 60s and 70s that succeeded in eradicating this virus, and it is the only human pathogen that has been eradicated. We thought we have eradicated polio, but no, we don't. Polio is coming back, if you follow the news. The vaccine contained a virus called vaccinia, which replicates in the vaccine recipient, and sometimes will cause severe side effects in immunocompromised people and could kill 1 in a million of the vaccinated. The picture that you see on the right-hand side, two kids. On the child on the right-hand side in the picture was immunized against smallpox with the vaccinia, and the one on the left-hand side was not vaccinated. And I think the difference is crystal clear. In the early 70s, countries started stopping, or they stopped using this smallpox vaccine because we eradicated the virus, and now the risks will outweigh the potential benefits. So it was logical to stop. Smallpox infection and the smallpox vaccine, they both protect against monkeypox due to the similarity between the two viruses. So an increasing number of people have become vulnerable to monkeypox over the past 50 years because we're not vaccinating against smallpox anymore. So that could be another reason to explain why monkeypox is emerging now. A little bit about the epidemiology of the disease. It was the first reported human case, as I mentioned, was in Africa. It has been found in several Western African countries. Most cases were in the Democratic Republic of Congo. Cases outside Africa has been linked to travel or importing animals. We can say that this virus is endemic in West and Central Africa, and occasionally may cause outbreaks outside Africa, but most of them can be quickly contained. At least this is what happened in the history, or die out by themselves. There's a term that epidemiologists use. It's called R0, which is the number of people who will contract a disease from a person infected with this virus. In case of SARS-CoV-2, the original strain was 2 to 3. So every single infected person would pass along the infection to about 2 or 3. Delta variant of SARS-CoV-2 was 8. Omicron is believed to be higher than 8. But for sense of comparison, monkeypox is low. It's considered low R0 value, somewhere between 1 or 2. So every infected person will potentially pass it to 1 or 2 others. It's not highly transmissible as smallpox or measles, and certainly not like COVID. It's not considered contagious before symptoms appear. And this is another big difference because asymptomatic people can transmit SARS-CoV-2. It's very rare, or people think that it would never happen or would rarely happen because the symptoms, as we're going to talk about in a minute, are obvious because it causes a lot of skin lesions. So it's hard to miss. But with SARS-CoV-2, if somebody has a mild disease, you could potentially go to work and meet with people and transmit your infection to them without knowing. There are 2 transmission cycles, an endemic cycle and a non-endemic cycle. The endemic cycle is what we had learned about when the virus was limited to African countries. It was mainly circulating between wild animals. We think possibly rodents and primates. And then occasionally from contact with wild animals, humans will get infected. But it won't go too far. Travel will take the infected person to a new place. And that's what we see right now is the non-endemic cycle is now what we see in the outbreak in Europe and the US mainly, where the virus is transmitted by close contact with an infected person or its body fluids. The virus can be transmitted through contact with an infected person or an infected animal, or even contaminated surfaces. Typically, the virus would enter the body through broken skin or also through inhalation, and it can get through the mucous membranes of the eye, nose, or mouth. Transmission can occur through close contact with body fluids of an infected person, sores, or any items that touched fluids from this infected person, like bedding, towels. The virus can also spread by inhalation of large droplets produced by sneezing or coughing, but that requires close contact. An important feature of pox viruses is that they are very sturdy. They can survive in the environment for a long time outside the body, which makes surfaces such as bed sheets and doorknobs potential vectors of transmission. And in the past, people typically caught the virus by coming in close contact with infected animals, which could be through an animal bite, scratch, contact with body fluids, feces, or consuming insufficiently cooked meat. So let's evaluate the risk of transmission. Who is at highest risk of getting the infection? The high risk is coming from contact with infected skin lesions, which occurs during sex, cuddling, hugging, and touching contaminated clothes, towels, bedding, shared utensils. Medium risk is associated with crowded indoor parties, and low risk is usually from like if you go out in the store and go to the fitting room and try pieces of clothing, touching door handles, and sitting in public transportation or going to office or school, because you need to have close contact with an infected person. And if an infected person has symptoms, we would expect that this person will stay at home. Symptoms, usually the virus would start replicate in the body of an infected person and spread via the bloodstream. The symptoms would appear usually within 1 or 2 weeks after infection. It starts as flu-like symptoms, like fever, headache, fatigue, muscle pain. Another important feature is you see enlargement of lymph nodes in the neck, under the armpits, in the groins. And a few days later, skin rash would appear. And this is very characteristic of monkeypox. It usually starts on the face and then would spread to other parts of the body. And these symptoms would last for 2 to 4 weeks. And then most people will recover without any medication, just symptomatic treatment and supportive care. Sorry for the pictures, but I had to show you how the skin rash looks like. This is how it appears on the face and on the hand of an infected person. And it usually goes through stages. It progresses from a small flat red bump to something that's filled with liquid. It becomes like a vesicle. And then with time, it develops a scab that would heal and fall down after a few weeks. The risk of complication is higher for children, adults who are immunocompromised, pregnant women, and the virus may infect the fetus and cause miscarriage, and people who have certain skin conditions such as eczema. People with broad range of immunocompromising conditions are at particular risk for severe disease, and that includes people with HIV, untreated HIV, people with cancers, organ transplant patients, and people with certain autoimmune disease. The skin rash most people get due to monkeypox infection can be very painful, and that may require hospitalization to alleviate the pain and discomfort. And most cases that led to death, it was because the virus was widespread throughout the body and infected the brain and lungs, and that what kills people. The current outbreak is certainly different. There are so many cases outside Africa, which is highly unusual. Anyone, let me just make this clear, anyone can potentially infected, can catch and transmit the virus. But the number of cases in women and children in this outbreak has remained relatively small. Although monkeypox is not known to be sexually transmitted, most of these cases, about 97.5%, according to WHO data, most of these cases occurred in men who have sex with men, or at the MSM community. We don't know exactly why, but we can also speculate. The virus may have made its way into a highly interconnected network within the MSM community, where it continued to spread. And perhaps because of this community is more densely connected, and they change partners more frequently, and more likely to have several partners at the same time. So that could have facilitated the spread of this disease. These are again data from WHO. The bars in purple are the cases in males, and the orange are female cases. So most of what you see, most of what we have are male cases, and it's mostly reported through sexual encounters. Can we consider it a sexually transmitted disease? Perhaps, but it's not the only way. It's not an exclusive route of transmission for this virus. Although it has not previously been associated with sexual preference, clearly sexual connections among the MSM community play a major role in this outbreak. It's very difficult to disentangle whether the monkeypox is transmitted sexually or just through skin-to-skin contact, which occurs during sex. It's very hard to figure out whether it's sexually transmitted or because people get in close touch. Many cases in the recent outbreak have presented with lesions in the genital area, and the viral DNA or even infectious virus was detected in the semen of some patients. But it's not yet clear whether this virus replicates in seminal cells or in the genital tract. So this is like an open question. Scientists speculate that it hasn't changed its transmission routes, but we still need to do further studies to clarify this important question. How the current outbreak started, we're not sure. The virus sequences from the current outbreak closely resemble that of monkeypox that's found in West Africa. The sequences analyzed so far are nearly identical, which suggests that they can be traced back to a single case. The simplest explanation is that the person who had the first non-African case this year, who hasn't been identified yet, became infected through contact with an animal or a human carrying the virus while visiting West Africa, and then took the virus to Europe, and then the outbreak started. Can certain mutations explain transmissibility? The monkeypox genome is made up of double-stranded DNA. Viruses are classified into either RNA viruses, such as SARS-CoV-2, which causes COVID, and DNA viruses, such as monkeypox. DNA viruses in general tend to mutate less than RNA viruses. So if you look at the graph on the right-hand side, this yellow dot is the evolutionary rate of double-stranded DNA viruses, such as monkeypox. If you compare it to the blue one, which is single-stranded RNA viruses, there's a big difference in the mutation rate and evolutionary rate. On average, pox viruses tend to mutate once every year, not crazy like COVID. A recent paper published in Nature Medicine shows that the current virus had mutated about 50 times in the past 4 years. So that's unusually high. But are these mutations responsible for making this virus more transmissible? Did the virus become more transmissible through the sexual route due to some mutations? We don't know. The size of the genome is huge compared to, relatively speaking, compared to other viruses. It's 200K base pairs. If you compare it to SARS-CoV-2, it's just 30. So for scientists to understand or to establish a connection between a certain mutation and a change in the behavior of the virus, it would take a lot of efforts to figure this out. It would take a lot of experiments, a lot of work. For SARS-CoV-2, maybe it was easier, but not certainly for monkeypox. It's unclear so far whether these mutations made the virus more transmissible or allowed it to transmit through a new route. This is a global phylogeny. Scientists like to analyze sequences by building phylogenetic trees to study the relatedness of viruses. So the current viruses circulating are linked to what scientists call clade 3, and they are very closely linked to the West African strain, which is good news to us because it's not as fatal as the other strain. We can diagnose this virus by PCR, and I'm sure you've all heard of PCR during COVID, but sample collection might require precautions from nurses and clinicians. They usually swab the skin lesions, and then you can check for the viral DNA by PCR in this sample. But people need to take precautions to avoid getting infected. Controlling infection relies on isolating the infected patient, avoiding any sexual encounter with an infected patient, and thorough decontamination of surfaces, because as we mentioned earlier, it can remain viable for a long time. Treatment, we have supportive care just to deal with the symptoms, reduce the pain and fever until the patient recovers. Sometimes the patient may require antiviral treatment, specific antiviral treatment. We have 2 drugs, brincidofovir, which is an old drug that is active against several DNA viruses, It has some activity against monkeypox, but we have another more potent virus that was developed. We have more potent drug that was developed specifically to treat orthopox viruses, and this drug is called tecovirimat. So this is a drug that's available, maybe not widely available now, but we have it. And also patients can be treated with immunoglobulins. Vaccines is an important topic that we need to discuss. Mass vaccination doesn't seem to be necessary, at least for now. Some countries are using a method called ring vaccination to contain the spread of the virus by offering the vaccine to healthcare workers and close contacts of known cases. Because monkeypox is closely related to smallpox vaccines can provide protection against monkeypox, and it's thought to be around 85% effective. There are 3 generations of smallpox vaccines. The first generation is vaccinia, and I'll tell you what a vaccinia virus is in the next slide. The second generation is a vaccine called ACAM 2000, and this is a live attenuated replication competent vaccine. And finally, the third generation is called modified vaccine Ankara, which is produced by a Danish company called Bavarian Nordic, and it's licensed in the US under the name Genius or Imvanix in Europe, and it's a non-replicating vaccine. Vaccinia is obsolete. We don't have it anymore. And then the 2 vaccines, the second and third generations, are in short supply. Vaccinia is a very old virus. And maybe you've heard of the story of the English doctor, Edward Jenner, who noticed back in the late 18th century that milkmaids who had caught cowpox were protected from smallpox. And that's the origin of vaccine. That's how vaccines came about. And he started vaccinating people with cowpox to protect them from smallpox. And after a while, it became easier to harvest the vaccine from the vaccinated rather than from cows. So once a human was vaccinated with the cowpox virus, they will develop pustules. And a few days later, the virus can be taken by puncturing the pustule and passing it along to the next person. However, vaccinia virus is genetically distinct from cowpox because it was cultured or passaged for a long time in human-to-human transmission chains. It can transmit from a recently vaccinated person to an unvaccinated contact. So we don't have it anymore. This is a very old vaccine. This is like the classical way of vaccination. In most of the vaccines, pretty much everything that we see today originated from this story. ACAM 2000 is a cell culture based, so it's a vaccine produced in the lab using cells cultured in the lab. It's not by taking the virus from a vaccinated person and giving it to an unvaccinated. It's under control, under lab control. Developed by a company called Emergent Biosolutions and was approved by the FDA in 2007 and replaced the old vaccines, but it didn't have application because the disease was eradicated, but it kept as stocks for in case of a smallpox outbreak, or if the virus comes back, or the most worry was about biowarfare. If someone uses smallpox for malicious purposes. So we've kept, there are smallpox stocks kept in America and Russia, and the US government keeps a stock of the vaccine to be used in emergency. Similar to the smallpox vaccine used in the eradication campaign, it can still cause rare, severe life-threatening side effects, and even death in people who have compromised immune systems. May be especially risky for children and for people who are pregnant, immunocompromised, or living with HIV. One reason why the US could not control the outbreak is because about 40% of cases are in HIV positive individuals. So it's very risky to give them this vaccine. It requires 1 dose, and it constitutes the majority of the current US vaccine stocks. The latest and the best version of the vaccine is the MVA. And this came from a German microbiologist in the late 50s who took a strain of vaccinia and started to grow it in cells obtained from chicken embryos. And after several years of passing the virus in these chicken embryo cells, the virus had changed or had mutated so much that it could no longer reproduce in most mammalian cells. But it can still induce an immune response. Okay, so it's a non-replicating vaccine. It's called MVA because the original strain came from this Turkish city. And now the virus was further weakened and brought to the market by this Danish company, Bavarian Nordic. Non-replicating, so it causes fewer side effects. It requires 2 doses given within 2 weeks, 4 weeks apart. And it can be given within 4 days of exposure to prevent the onset of disease. If you remember, I told you that symptoms will take some time to appear. So if you can diagnose the infection early enough and people can have access to the vaccine, that would help in alleviating the symptoms. How well this vaccine exactly protects humans from monkeypox is uncertain. Usually we measure vaccine efficacy through clinical trials. And I'm sure you've heard about this during COVID, but we cannot infect people with monkeypox. It's unethical. So the license for this vaccine came from animal studies, where it showed that it protects monkeys and it protects dogs, plus data showing that it induces a strong immune response in humans. So if you vaccinate a person and take a serum sample and check for antibodies, it does induce antibody production, but we have not tested this under clinical trial settings yet. And I'm gonna try to end this with a positive note. And I'm sure maybe some of you are now asking or thinking about whether this will become another COVID. I will tell you why we think it's not going to be another COVID. It does not transmit as easily, and therefore unlikely to cause another huge pandemic as COVID. Most people will recover spontaneously within a few weeks without treatment. Unlike SARS-CoV-2, which spreads through aerosols, which can travel for long distances, monkeypox spread requires close contact, which means that a person with a monkeypox is likely to infect far fewer close contacts than someone with SARS-CoV-2. Unlike SARS-CoV-2, which can spread without causing symptoms, monkeypox does not usually go unnoticed when it infects a person. And that's a good thing. Because of obviously the lesions that it causes, it's hard to miss. Monkeypox takes about maybe like 12 days to cause symptoms, which gives doctors a window of opportunity, maybe a few days after exposure to vaccinate and avoid disease. This is not an option with COVID. And many older adults, which we consider as the most vulnerable group, are at least somewhat protected by the old smallpox vaccination. And there's a paper in Nature Medicine that shows that the duration of immunity from smallpox vaccination can remain for about 25 to 75 years. So the older generations have at least some degree of immunity against this virus. Can this outbreak be contained? It's hard to put a timeline. We have some tools that we didn't have during COVID. We have drugs, we have vaccines. In combination with the classical isolation and quarantine procedures that you're all familiar with, which helped to contain monkeypox outbreaks in the past. We can certainly use them again. Immunity to smallpox is protective against monkeypox. So that will help in containing the outbreak. However, if the monkeypox virus establishes itself in a wildlife reservoir outside Africa, this could cause a huge public health concern, because this virus will establish a reservoir in a new place, and that will be a constant source of infection. It's not going to be like what we had seen in the past. And there was a case of monkeypox transmitting from a human to his dog. Okay, so even it can infect also pet animals. So reservoirs in pet animals or wild animals is what we worry about, because it would allow this virus to stay for a long time. Okay, but it's not seen as another huge concern of a pandemic. Okay, and I would like to end here, and thanks for listening. And I would like to take any questions that we haven't yet covered.
Yes, thank you very much. We are running out of time, so we'll make the Q&A to be something like a speed date. I'll quickly ask a question, ask some of the questions we have, and if you can quickly give me the response. So the first question has to do with reservoir, and the question is this: why don't we still have a definitive answer regarding the animal reservoir of these virus? And can we be looking at not just one or potential of having more than one reservoirs for the monkeypox virus?
So let me clarify. So the question why there is